My name is Frederic Gmeiner, and I'm a second-year PhD student at the Human-Computer Interaction Institute at Carnegie Mellon. And today I'm excited to share our research on exploring challenges and opportunities of supporting designers in learning to co-create with AI-based manufacturing design tools. Modern manufacturing processes allow designers to create parts that are optimized for strength and reduction of weight, costs, and environmental impact. However, creating these parts can often exceed the cognitive capabilities of designers. Increasingly, computer-aided design tools incorporate AI-based features to assist designers in generating such complex parts based on a designer's various goals, like reducing the weight of an electric wheelchair component or generating parts using emerging manufacturing processes. In both examples, working with AI allows designers to create designs that would be extremely tedious or even infeasible with AI support. Such generative AI tools are often seen as co-creators, since they take more agency and autonomy in parts of the human-AI design process. However, working with AI co-creators is more like a collaboration with an agent as opposed to a tool, which requires new ways of working and also learning how to work together. Even without AI features, working with professional feature-rich design software already requires substantial and continual learning, which is frequently studied in HCI, how learning such systems can be supported through interactive interfaces. But little is known about how to support designers in learning to work with AI tools that take on a more active and collaborative role. Therefore, we ask the following questions. What challenges do designers face when learning to co-create with computational AI tools? How do designers overcome these challenges? What are effective strategies to support designers in learning to co-create with computational AI tools? And what are designers' needs and expectations for human-AI co-creation? To answer these questions, we conducted a series of Think Aloud studies and interviews with trained designers without prior AI co-creation experience to observe how they learn to work with two AI CAD tools in the context of manufacturing and advanced material design tasks. We found that most designers struggled to create satisfying results not because of the tool's interfaces, but because it was a new kind of interaction. In this paper, we highlight the challenges designers faced in learning to effectively co-create with these tools and identify several design opportunities to inform future support interfaces of AI design systems. Half of the participants had a mechanical engineering background and designed a light and strong mounting bracket for a ship engine using Autodesk Fusion 360 generative design. Participants needed to specify the mechanical design criteria such as loads, bolt connection clearance, and boundary conditions. Next, participants ran the solver and evaluated the AI-generated solutions. To make refinements, they would start over and tweak parameters until satisfying results were generated. The other half were industrial and architectural designers, designing a bike bottle holder out of shape-changing material using the software SimiLearn. This tool uses ML-driven real-time simulation and optimization to enable the creation of objects out of morphing materials, which can transform from a flat piece into a volumetric shape when triggered by heat, making it challenging to design for. Designers first define the grid and bending actuators, then participants simulate the design, observe the predicted transformation, and iteratively change the grid and actuator parameters. Alternatively, participants might use different AI functions to optimize the grid toward a targeted shape. The study was conducted remotely and followed 4 phases. After onboarding, designers began working on the task while thinking aloud. Because of the open-ended task, they continued working on the project after the first session unattended until they had produced their final design. Participants documented their sessions by cloud video recording, and after task completion, we conducted an interview. By evaluating the design outcomes and analyzing the Think Aloud videos and interview recordings using video interaction and thematic analysis, we served major challenges designers faced, but also successful learning strategies for co-creating with the AI tools. Overall, participants saw potential value in the systems. However, most faced unresolvable challenges in learning to effectively co-create with the tools. In the engine bracket task, it was surprising that most struggled to perform this generally familiar task. Only one designer could create a design that met all requirements, and few were satisfied with their solutions. Most designers learned how to specify basic requirements, but many failed to correctly specify structural loads, resulting in designs that were either too heavy, too weak, or larger than the required dimensions. For the other task, designers generally perceived designing a bottle holder as not difficult, but working with shape-changing material was new and felt unintuitive. We observed that many avoided using the two AI-assisted features after unsuccessful attempts and worked manually. Most didn't learn to create satisfying outcomes, except for one designer, as indicated in the table. We highlight 3 significant challenges that designers faced. I'll explain these briefly in the following slides, starting with the first one. We observed that designers were often confused about the generated results and had difficulty understanding the cause and remedy of AI outcomes. This often occurred when generated solutions contained minor flaws, such as surface bumps, holes, or twisted geometry. Designers wondered about the AI's design rationale and didn't know if such features were intended or caused by algorithmic glitches. They could also often not make sense of apparent structural issues in the generated designs, for example, when the parts were unreasonably thick or thin. We also observed that designers were uncertain whether the AI or the user was responsible for fixing the problem, and sometimes designers accepted imperfect results and attributed the flaws to the system. We also found that designers frequently expressed challenges in sharing control with the AI-based design tools, noting that these tools often seem to dominate the design process. In those situations, designers either gave up and accepted unsatisfying results, improvised to work around the AI, or abandoned the AI assistants altogether and worked manually. We also observed that designers often had difficulty communicating design goals to the AI system. For example, designers were unsure about the use and implication of certain parameters, and they often relied on the system's default settings and made assumptions about their effect. Instead of looking up helpful resources, they tried figuring out a parameter's effect on the generated designs, but it was often hard or impossible to trace back parameter influences from the final result. Even though most designers struggled to learn to co-create with the tools, some designers employed successful strategies that helped them learn to work better with the AI features. For example, we observed that 2 designers systematically experimented with the tools to understand better the AI's behavior and capabilities, which helped them to refine their mental model by comparing different parameter values' effects on the final result. Another strategy was actively abstracting and explaining problems to themselves. We observed that when facing fundamental challenges like overconstraining the engine bracket, some designers could understand and overcome these issues by sketching out a free body diagram and explaining the acting forces and constraints to themselves. To gain insights into how designers can be better supported in learning to co-create with AI tools, we conducted additional Think Aloud sessions where designers were paired with peer guides who had prior experience using the tools to support them during the task in co-creating more effectively with the AI-driven features. By observing the human guide support strategies and communication patterns, we derived insights into when and how to effectively support users in learning to co-create with the systems. Successful peer support strategies that we observed were that guides provided designers with step-by-step instructions for setting specific parameters, often in response to designers showing confusion or struggle. Guides were especially sensitive to moments when designers signaled uncertainty or when designers verbalized knowledge gaps with hedging expressions such as "I don't know" or "I assume." In these situations, the guides often intervened and offered support or suggested alternative design strategies. We also frequently observed situations where the guides prompted feedback from designers each time the tool solver had finished, for example by asking, "Is that what you envisioned?" These prompts triggered designers to reflect on the generated designs, which helped the guides better understand how to provide support. Lastly, nonverbal communication was essential to building understanding between the designers and guides. For example, guides used the screen annotation feature to highlight elements they spoke about by circling or drawing arrows, or used the mouse cursor to emphasize design features through circling or pointing gestures. Overall, our findings show that designers face significant challenges in learning to effectively co-create with AI tools and suggest that these learning challenges go beyond learning the tool's interfaces. For example, a major challenge relates to how designers specify all required parameters upfront instead of modeling and testing a part step by step. This workflow is different from the usual iterative design process and requires designers to think through the design problem in advance, which is challenging. Our findings suggest that these new learning challenges also require new support strategies. Here we highlight several design opportunities. First, co-creative systems may interactively scaffold inductive learning of AI's capabilities and limitations, for example by offering a set of hands-on guided experiments to better understand the system's response to specific parameter inputs to help them develop useful mental models of an AI tool's behavior. Second, by actively prompting designers' planning and reflection, future co-creative systems could promote designers' explanation, which can support understanding and problem solving. For example, the system could prompt feedback and reflection on generated designs by asking deep reasoning questions about the results and help coordinate further actions. Third, our results show that designers felt a lack of the tool's awareness about the design context. To improve that, future systems could derive their user model through explicit and implicit mechanisms by asking the user more information about the specific design task or inferring design goals from user behaviors. Finally, our findings show that designers felt communicating with the AI was like giving instructions without receiving much feedback. In contrast, results from the guided sessions reveal that designers and guides discussed goals and strategies by pointing at features with the mouse cursor or by sketching to develop shared mental models. Even though these modalities are underutilized in generative design systems, they may also help designers communicate design goals to future AI systems. Our research in this paper focused on providing a better understanding of how designers learn to work with AI-based manufacturing design tools and identified several support opportunities to improve future designer AI co-creation that combines the strength of both human and AI systems to achieve complex designs that neither could achieve alone. Thank you so much for listening to our presentation, and please check out our full paper for more details.